What we're going to do today is work on simplifying complex fractions. Now, what a complex fraction is, it's a fraction that has a fraction or fractions in it. So a complex fraction. Fraction that contains a fraction in its numerator or denominator. We can go about simplifying these different ways. And we've done something similar already, where if we had like x minus 3 over x divided by, say 3x over x minus 10, this can be written as a complex fraction. Remember, the division symbol and the fraction bar are interchangeable. So what we want to do is, since we know how to do this, we know what to do once we get to this stage. We want to get our complex fraction to look like that. So if we look in our examples right here, we don't have that right now. What we need to do is to have our numerator be a single fraction and our denominator to be a single fraction. Our numerator is one fraction, but in our denominator right now, we have an addition symbol. So we're going to focus on the denominator, and we want to write that as one fraction by getting common denominators. Like we did yesterday, or a couple days ago, we said, can we simplify this, adding a rational expression? Well, we can do that. If we multiply the top and bottom by x plus 4 over x plus 4, and this one by x over x, what we're going to be left with is 5 over x plus 4, so that numerator, over x plus 2 times x plus 4, all over x times x plus 4. So what I did is I multiplied, I got my common denominator, and then I added across. So now what I'm going to do is going to do x over x plus 4 multiplied by this thing flipped. So x times x plus 4 over x plus, and I'm going to distribute this as well, x plus 2x plus 8. I want to simplify that denominator first. So I'm going to have x over x plus 4 times x plus 4 over 3x plus 8. So now, since we're multiplying, we can look at the numerator and denominator and start crossing things off. I don't know why I changed this to an x, so let's fix that. This was a 5. So anyway, and that we get 5x over 3x plus 8. And that's our simplified answer. If we look at letter B, we notice that we have in the numerator an addition symbol, and in the denominator a subtraction symbol between our two rationals. So I'm going to multiply this by x minus 5 over x minus 5, this one by x over x, and then in the denominator, x minus 5, x minus 5, x and x. So in my numerator, I'm going to get 6x over x times x minus 5 plus, and I'm combining this as one fraction, plus x minus 5 over, And then I'm going to get 3 times x minus 5 minus 2x over x minus 5. So now that we're have just a simple fraction over another simple fraction, we can combine like terms and then multiply by the reciprocal. So in the numerator of the numerator, we have 6x plus x minus 5. So that's going to be 7x minus 5 over x times x minus 5 times, and then we're going to flip this fraction, is going to be x times x minus 5 over 3x minus 15 minus 2x. So we're crossing these off, and then the top is going to be 7x minus 5 over, we can simplify this to x minus 15, because we can combine these like terms. And this is going to be our final answer. So this is a confusing process. The key is to not multiply out your parentheses. Now, if you have a number in front, you can distribute, and that would be a good idea. Like I did this, I distributed that 3. But for the most part, you want to keep things in factored form so you can cross things out. At some point, if you need to factor to put something in factored form, then you would do that as well. So let's look at the next page. So here we have some negative exponents. Remember, negative exponents move things to the denominator. Now you may say, well, can't I just move this down here? Because of this subtraction sign, 4 minus k to the negative second, we can't do that. So this is going to be 4 minus 1 over k squared over 2 over k minus 1 over k squared. So remember, this 4 up here is really over 1. So now if we look at the numerator up here, we can see that the GCF of those numerators is just going to be k squared. So I'm going to multiply the top and bottom by k squared. Then down here, I'm going to multiply just the first fraction by k. Notice I don't have to do anything to this fraction because it already has k squared in the denominator. And that's the same reason why I didn't do anything right here, is because I don't need to. So we're going to have 4k squared minus 1 over k squared over 2k minus 1 over k squared. So when I'm writing this out, I am skipping some of the more minor steps. Like I'm not writing out over here 4k squared over k squared and then minus 1 over k squared. Because I know that they'll have the same denominators, I'm just going to write it as one fraction. Same thing down here. Instead of writing out 2k over k squared minus 1 over k squared, I'm just going to combine it into 1. So now we can write 4k squared minus 1 over k squared times k squared over 2k minus 1. Before we cross things off, let's factor this, because that is a difference of 2 squares. This is going to be 2k minus 1 times 2k plus 1 over k squared times k squared over 2k minus 1. And then we can cross off the k squareds and the 2k minus 1s, and we're left with just 2k plus 1. So we're using that idea of simplifying rational expressions, but we just have to get the common denominators first. And it's going to take some practice to get good at this. It's like everything else we've been doing. It seems hard at first, but once you practice it more and recognize what the common denominators would be, it gets much easier. All right, let's look at letter D. The nice thing about letter D is that the denominator of the big fraction doesn't have anything being added or subtracted. Like, we don't have two separate fractions. We just have one fraction here, and we have one fraction here. So this makes it a little bit easier to handle. Now, I want to factor this numerator and this denominator. So the numerator will factor into x minus 3 times x plus 2. And the denominator is going to factor to x. And then on the outside is going to be, the inside x plus 4, multiplied by the reciprocal x over x plus 2. So we got to get good at remembering that this fraction bar is the same thing as division, so we can multiply by the reciprocal where we flip this fraction. Now we can cross things off the numerator and denominator. We have an x plus 2 on the top and bottom, we have an x on the top and bottom, and we are left with x minus 3 over x plus 4, and that would be our final answer. All right, let's look at this one. Now, you may see that the top is not a fraction, the numerator of the big fraction is not a fraction in itself. However, we can write this as 2d over 1, if that helps you with spacing things out, over, let's move this over here for a little bit. Well, let's multiply the denominator's fractions. The first one will multiply by n over n, and the second one will multiply by j over j, which means the denominator of my smaller fraction is n times j. And we're going to have n times d plus d times j. Now, you can't cancel anything out in this one because we have an addition sign here. So now we're going to rewrite this 2d over 1 times n times j over n times d plus d times j. In the denominator right here, we can factor out a d because they both have a d in common. So we have 2d and j over d times n plus j. We can then cancel the d from the top and bottom. We have 2nj over n plus j. And like I said, you can't cancel out the n's and j's because of that addition sign there. So this one required us to do a little bit of work. So in this problem, I want to recognize and say, well, if I multiply this fraction by 2 over 2, I want to get 10 in the denominators, and that will be the least common denominator of my top fraction. And then my bottom fraction, multiply by 2 over 2, and that's going to give me 4 in the denominator of my bottom fraction, and that will allow me to then combine them as 1. So this is going to be x minus 2x over 10 over 2x minus 3 over 4. All right, now I can rewrite this as x minus 2x is negative x over 10 times 4 over 2x minus 3. So this is going to give me negative 4x over, I'm not going to distribute that 10, and the reason for that is I can tell that 4 and 10 can be simplified, and I can divide the top and bottom by 2, so it's going to be negative 2x over 5 times 2x minus 3. And that will be my final answer. So your algebra skills have to be really sharp to do these well, because it's so easy to make a mistake. If you're not organizing your work in a neat way, it can be very messy to try to find and follow your thinking. So let's try this last one here. You'll notice how I haven't stopped to give you guys a chance to try any of them, because I do know that this is complicated and it's very easy to mess it up. So I think it's important that you can see, each step of these problems. Now, if you think you could do this one, go ahead and pause it and try it, but I will walk you through this one as well. So the first thing I'm going to do is I'm going to multiply the first fraction in the numerator by x over x. So I can have a 3x squared in the denominator. And then this one will be 3 over 3 to give me 3x squared in the denominator. The bottom fraction here already has a common denominator of x plus 1. So that's going to make things a little bit easier. So I'm going to have 4x plus 2 times 3 is 6 over 3x squared over x minus 4 over x plus 1. Because they have the same denominator, I can make it one fraction. That's going to lead me to 4x plus 6 over 3x squared times x plus 1 over x minus 4. Now I can factor out a 2. So it's going to be 2 times 2x plus 3 over 3x squared times x plus 1 over x minus 4. And now I'm going to write that all as one fraction. 2 times 2x plus 3 times x plus 1 over 3x squared times x minus 4. I can't cross anything out, so I'm just going to leave my solution like this. And so that's it for simplifying complex fractions. Like I said, the more you do these, the easier it becomes. That's why we just spent time adding, subtracting rational expressions, because in that lesson we worked with finding common denominators and least common multiples, and we're also doing that in this instance here. So thank you for watching. Make sure to like the video and subscribe.